It was supposed to be an easy 8-day-long mission. 2 NASA astronauts couldn't even imagine they would get stranded in space for at least 9 months. Their task was to test a brand new spacecraft, Starliner. They were hoping to return it to Earth as soon as possible so engineers could check it out and send it on a new flight. But from the very start, it didn't go as planned for Butch Wilmore and Sunita Williams, experienced astronauts who had both been to the International Space Station before. They were supposed to depart on the 6th of May, 2024, but had to postpone departure for 1 month because of a leaky valve in the upper stage of their rocket. When they finally took off on the 5th of June, new problems started before they even got to the station. There were failures in some of their thrusters and, later, leaks in the gaseous helium. It's important because it keeps the thrusters pressurized. Boeing, who built the new spacecraft, and NASA focused on solving those problems and figured out it wasn't safe for the astronauts to fly back home on the Starliner. They didn't just leave them on the ISS, of course. NASA came up with a plan where Butch Wilmore and Sunita Williams would come back home on a SpaceX Crew Dragon spacecraft. It took off in September of the same year with 2 empty seats out of a total of 4. The only problem is that it wasn't supposed to come back until February 2025 at the earliest. In a press conference from the International Space Station, Wilmore and Williams admitted it was heartbreaking to watch their spacecraft depart without them, but they were trained to expect the unexpected. They keep receiving messages of support from Earth, and they aren't at all sad to spend more time in space, as they say it's their happy place. Mr. Wilmore gets up every day at 4:30 in the morning, and Miss Williams at 6:30. They do at least 2 hours of exercise at the space gym every day to reduce the loss of bone density. Another big problem is sleeping in space. The space station has 6 tiny sleep pods, each about the size of a phone booth. Inside, there's a sleeping bag, a little storage area for snacks and personal stuff, and even 2 laptops attached to the walls with bungee cords. The pods aren't completely soundproof, so astronauts sometimes wear headphones to listen to music or calming sounds from Earth to help them fall asleep. But here's the problem. There are more astronauts than sleep pods, so 3 astronauts have to find other places to sleep. One of them sleeps in a simple backup sleep chamber inside the European Space Agency's Columbus lab. Butch Wilmore is roughing it in just a sleeping bag inside the Japanese Space Agency's lab. When they planned this mission, Butch was only supposed to sleep like that for 8 days, which didn't sound that terrible. Another problem they had to deal with was that they didn't pack enough clothes for several months. So, astronauts had to savor what they brought for the first 2 months until a resupply vehicle delivered fresh outfits, along with hardware, fruits, and vegetables. The astronauts have a super packed schedule that's managed by a computer tablet. It tells them what tasks to do, when to take breaks, and even when to eat, all in 15-minute chunks. A little red line on the tablet moves through the day in real time, showing them if they're on track or running behind. At first, Butch and Williams were working on the Starliner spacecraft, testing all its systems like communications, life support, and power. Once they finished that checklist, they started helping the other crew members with science experiments and maintenance tasks. The best-case scenario is now a late March return, and if it actually happens, the Starliner crew will spend over 270 days in space. An average mission on the ISS lasts around 6 months, so it's already way longer, but not close to the record time. The current American record belongs to astronaut Frank Rubio, who stayed in space for 371 days in a row. He lived on the International Space Station from September 2022 to September 2023. When Frank first went to space, the plan was for him to stay there for about 6 months, but it didn't go as planned. In December 2022, a meteoroid, or maybe a piece of broken satellite junk, crashed into the spaceship that was supposed to bring him and his 2 crewmates home. The spaceship was damaged so badly that it wasn't safe to use anymore. The two astronauts who were on that spaceship also had to stay on the ISS with Frank for 6 extra months until another spaceship went to space and rescued them. During his mission, Frank Rubio zoomed around Earth about 5,936 times. Altogether, he traveled a distance of 157 million miles. It's like going to the moon and back 328 times. Frank also went on 3 spacewalks and spent 21 hours outside the space station. One of Frank's big jobs was to do scientific experiments. He studied how bacteria behave in space, where there's no gravity pulling things down like on Earth. But his favorite experiment was taking care of a tiny tomato plant and watching it grow. Frank admitted that being away from his family for so long was really hard, but it's not the only possible hardship on such an extended space stay. Space agencies have entire departments that study the effects of space on the human body. In one of the studies, called Twins, scientists compared 2 identical twin brothers, Scott Kelly and Mark Kelly. They're both astronauts, but for this study, Scott spent a year on the ISS and Mark stayed on Earth. By comparing them, scientists could figure out how space changed Scott's body compared to his twin. He said it took him at least 6 months to feel like his usual self again after coming back to Earth. Scientists noticed predictable weight loss and bone mass loss, but they didn't expect to see changes in his DNA. They found that his telomeres, which are like tiny protective caps at the ends of DNA strands, got longer while he was in space. But sometime after he got back, he had more short telomeres than before. It looks like the damage was permanent. It must have to do with radiation, which is one of the biggest dangers for astronauts who stay in space for a long time. It can damage DNA, and that can increase the risk of some really serious health problems. Astronauts need protection from radiation, not just while they're flying in space, but also if they live on the moon or Mars someday. Scientists are working hard to find ways to keep astronauts safe from this invisible danger. Every space agency has rules about how much radiation astronauts can safely handle during their careers. Another big problem astronauts face is bone demineralization. It happens because there's no gravity in space pulling on their bones like there is on Earth. Without that pressure, their bones start losing minerals like calcium, which makes them weaker. Astronauts can lose about 1 to 1.5% of their bone density every month they're in space. When calcium from the bones gets into the body's waste system, it can lead to kidney stones. Because of these changes, astronauts coming back from space need time to recover. Another challenge in space is how the body's fluids, like blood, behave. On Earth, gravity keeps most fluids lower in your body, but in space, they float upward. This extra fluid in the head can push on the eyes, which might change how astronauts see. Some even develop a condition that can make it hard to focus their eyes, and sometimes the changes in vision can be permanent. When astronauts who spend a longer time in space, like Williams and Wilmore, return to Earth, doctors keep a close eye on their health with regular checkups. Scientists expect that their condition is going to be like that of 6-month astronauts.
The moon landing has unlocked one of the greatest achievements in human history. The world was going through a rough patch, so to see one of us up there was literally something out of this world. On July 16, 1969, Neil Armstrong, Buzz Aldrin, and Michael Collins became the first people to successfully leave Earth's atmosphere and enter a different one. It was Neil who took the first steps on the moon after careful precision in maneuvering the spacecraft. The Apollo 11 mission was the leap for humankind that everyone needed. When they safely arrived back on Earth, they were welcomed as heroes. It became every kid's dream to do what they did. They were in a capsule with a parachute that landed almost 1,000 miles off the coast of Honolulu with a crew waiting for them. They were the most famous people in the world at that moment. But that's not the end of the story. going up to outer space posed many potential threats, which nobody really spoke about. There was so much preparation that had to be made for the launch, not to mention training and studies. They didn't know what to expect, since it was the first trip of its kind in history. There was so much mystery behind the moon that scientists proposed a theory that the 3 astronauts may have caught some microscopic germs from the lunar atmosphere, which could be hazardous to people on Earth. As soon as they landed back on Earth, they had to stay in isolation for 3 weeks. The hype was real. The health community was extremely concerned about those extraterrestrial bacteria and didn't want to take any chances. The public was just as scared. The recovery helicopters hovered above. Rescue divers did a deep scrub on the capsule hatch with iodine to disinfect anything the capsule may have brought from outer space. Afterward, they were given the BIG, a biological isolation garment suit, to wear in the capsule before exiting into Earth's atmosphere. After they put on the suits, they were disinfected with bleach and taken to an aircraft carrier by helicopter to be escorted to a mobile isolation unit. The unit docked in Hawaii while they were in the mobile quarantine facility until it was flown to Ellington Air Force Base in Houston, Texas. They were then placed in the Lunar Receiving Laboratory. Over there, they had to spend another 15 days inside an airlocked room to lessen the risk of exposing themselves to the outside world. They had to stay in ultraviolet light to eliminate any microbes or bacteria from space. In fact, after each day, everyone working in the LRL had to disinfect themselves and shower to be safe. And in the case of them being infected with some lunar microbes, they had to also be in isolation, just like the astronauts. Inside the chamber, the 3 men had to find ways to entertain themselves. With 2 weeks left in isolation, they did what other humans would do in a closed chamber: talk all the time. Lots of laughing, joking, and every kind of interaction they could have with each other. Reports say that they were comfortable inside, but because there wasn't much to do in there, they got bored pretty quick. They ate well and had all the meals required to stay healthy. In the meanwhile, they enjoyed some activities like table tennis, working out at the gym, and even played the ukulele. Well, at least that's what Neil Armstrong did. Some of them used to jog back and forth in the hallway. Astronauts lose muscle mass when they stay in space for too long, so working out isn't just for fun, but mandatory. They even threw a party and celebrated Neil's 39th birthday in isolation. He had a cake with candles baked by one of the staff members of the LRL. In addition, they had some playing cards to entertain themselves, magazines, and media coverage of their mission. They also spoke to some of their family members when given a chance, with glass walls separating them or through a telephone. They respected each other's privacy and found ways to keep themselves busy whenever one of them was talking to a family member or discussing something in confidence. They also had to take daily medical tests and have long debriefings from NASA, separated by glass. They spent some time working on mission reports and finishing up some other paperwork. The cherry on top was when President Nixon visited them before they were sent to the LRL to congratulate them for being the heroes everyone looked up to. And after those 21 days were up, they were released from their isolation. Scientists found nothing scary in their system and nothing that they carried with them. There were no pathogens, microbes, or bacteria from the moon, which means that there wasn't any life on our neighboring rock floating in the air. The 3 men were finally able to go home to their families and enjoy the freedom of Earth's atmosphere. Eventually, the whole quarantine was dropped, but any astronauts going to the International Space Station have to stay in isolation before launching, so they don't bring any infections up there. Scientists have set their eyes on Mars for our next future home. Elon Musk's SpaceX wants to spearhead the mission up there and use robots as the first ones to set foot on the red planet. The Tesla bot was showcased in 2021 and can mimic us pretty well. It can do the everyday boring tasks we don't enjoy doing, like cleaning, buying groceries, and some heavy lifting. Thanks to the fact that they walk like us, we can get a good idea of how humans will move around on Mars. The bots can send reports back to Earth as soon as they get the data, and can probably study the environment if there are, in fact, extraterrestrial microbes living on Mars. But none of this will happen anytime soon. There are a lot of steps to be taken before we can see ourselves living on the red planet. The first challenge is getting there. Scientists predicted that it could take up to 9 months inside a large spacecraft following a carefully mapped route. It's likely there will be many robots helping around and a few humans specialized in various fields to help with anything needed. No doubt, it'll have proper sleeping quarters, an exercise room, and a recreational room, just to name a few. It'll be risky, but exciting. And after all those months of traveling, it'll be time for the landing that's going to be equally, if not even more, challenging. NASA used a special sky crane to lower Curiosity on the surface of Mars in 2012. So maybe we can develop some technology along these lines to set up before the arrival of the spacecraft. Once these things are figured out, it's time to get greased up and ready for the bumpy ride, settling. The initial steps have been studied, and the crew knows exactly what to do, what to build, and where to conduct everything. Robots and engineers will build living quarters, indoor farms, and the basic essentials needed to survive. Sure, they can bring a certain amount of food and resources that can last for years, but the main purpose is to be self-sustainable. We'll need to produce water, food, and breathable air if we want to make it up there. There's some evidence that Mars was once a water wonderland, so it's possible that there might be some water underground or in the ice caps. We can't grow crops without water, which brings us to our next challenge: growing food in the middle of a barren wasteland. We'd have to live in domes in order to breathe and walk around without a protective suit. So growing food in these domes will be a no-brainer. But with limited water supply for crops, we now have to find a way to produce water and mimic the conditions for plants to grow. Once these things are built and studied, then comes the next challenge: powering up the settlement. Solar energy is one of the obvious choices. This source of energy can power up fuel cells and nuclear batteries for our everyday use. And once we have all this up and running, we can finally say we got ourselves a settlement outside of Earth. Sooner or later, more ships will arrive, with more people settling and building a future out there. By then, we'd know if there are any foreign microbes that could pose a threat, so we wouldn't have to quarantine. And all it's going to cost are a few tens of billions of dollars, a small sum for the next big leap for humans. Many people would like to fly into space. Zero gravity, a stunning view of Earth from one side, and the boundlessly frightening black area from the other. Yeah, it's all cool. But don't forget that this journey can turn into a nightmare. Lack of oxygen, floating in outer space and staying in a spaceship for a long time without understanding when you can return home. This last thing happened to a Russian cosmonaut. His stay in space is one of the longest in the world. 33-year-old flight engineer Sergei Krikalev spent 311 days in zero gravity on the Mir space station. But that's not the most interesting part of this story. Sergei's long journey began on May 18, 1991. That day, he boarded a transport ship and went into space to the Mir space station. On May 20th, the docking with the station was completed. There, together with another engineer, Sergei performed his space duties. They went on spacewalks several times, did repairs, took care of the station, and conducted scientific experiments. When you have company and a lot of work, living in space is not so hard. But things got worse on the day when Sergei was supposed to return home. According to the plan, the mission should have lasted for 5 months. A new astronaut was supposed to replace the old ones. The transport ship had finally docked with the station. But on October 10th, only one astronaut returned to Earth. Sergei was left alone at the Mir station. He continued to work as the sole flight engineer of the crew. The station couldn't remain empty. They had to send someone to replace Sergei. He wasn't ready for such a long stay in space. He hadn't trained for it. But there was no choice. He couldn't just leave the station. 1 month passed. They informed Sergei that he would return home soon, but something happened that no one expected. They contacted Sergei and said he couldn't return, since the country that promised to bring him home no longer existed. During this time, a big crisis began in Russia. The cosmonaut's return was impossible, since no one had the money for it. Just imagine Sergei's condition. You are hundreds of miles from home in black outer space, completely alone, and have no idea how many days you have left to be there. The days passed slowly, weeks, then a month passed. It would have been much easier if being in space was not harmful to your health. But in conditions of zero gravity, the human body takes serious damage. First, it's a weakening of the muscles. The body doesn't receive the necessary load it needs, and the muscles are constantly in a relaxed state, leading to dystrophy. Yes, astronauts do a set of exercises every day, but this is not enough to keep the body in shape. In addition to muscles, bones begin to weaken and a person becomes weak. Even after 6 months of such a life, any astronaut needs a long time to get back into their previous shape after returning home. Also, there's a lot of radiation in space, which is dangerous for people. It comes from several sources at once. The main radiation comes from the sun. On Earth, we're protected from it, thanks to the planet's magnetic field. Almost all radiation accumulates in the upper atmosphere and doesn't reach us. This accumulation of radiation in the atmosphere is also bad for astronauts. But the worst radiation is the galactic one. It comes from distant stars and galaxies and has a powerful effect on all living things. Radiation provokes many unfavorable conditions and destroys the body at the cellular level. Now, all spaceships and the ISS are equipped with shields and coatings that reflect radiation. But still, it doesn't provide 100% protection. In space, the astronaut's immune system changes. There are no conditions under which immunity could improve. It seems that there's nothing wrong with the absence of many bacteria and microbes, but the body's defense is weakening. A person becomes more vulnerable to microbes that can be brought by another astronaut. You also have serious food restrictions. Food in tubes doesn't contain as many useful vitamins as it does in natural products. Without vitamins, the body weakens even more. And sometimes, astronauts have to go on spacewalks, which aren't easy. A spacesuit is a huge and uncomfortable outfit. It constrains your movements and puts pressure on your body. Work in space can last up to several hours. During this time, you sweat a lot. One of the suit's filters may be broken, and all the fluid released by your body can spread throughout the suit and reach your face. Your eyes may water. The drops could interfere with your vision. Thousands of dangers can await an astronaut during a mission in outer space. Imagine that you do some repairs and something goes wrong. The wrench jumps off the bolt and it flies out, for example. You try to catch it and unconsciously push off from the ship. You catch the bolt, but your body is already flying away. You have nothing to hold on to. But fortunately, you have a safety rope. Anyway, it can break off from your spacesuit because you attached it incorrectly. As soon as the rope breaks, your body changes the angle of flight. Now you're not just flying away, your body is spinning at this moment. The Earth and black space flash in your eyes. So you get it. There are definitely risks, but nothing like that happened with Sergei. All astronauts spend many hours training to be ready for any troubles. They gain good physical shape and lose it during the mission. Add to this the psychological factor. Your body weakens, you don't breathe fresh air, you can't see your friends, and you don't have the opportunity to return home. A small layer of wall separates you from the cold vacuum of space. All this causes stress, which also weakens your immunity and harms your nervous system. Fortunately, astronauts also get through serious psychological training. They can maintain self-control in the most stressful situations. But when you're alone in space for more than 6 months and don't know when you'll return, you can get seriously nervous. Fortunately, Sergei didn't panic. He performed his daily duties, trained, and of course, missed home. A month later, he received the same response. "We can't bring you back yet. The country is in a difficult situation." He felt worse every day. His strength was leaving him. He wasn't sure if he'd be able to survive. The most interesting thing is the station had a capsule developed to return to Earth. But Sergei didn't use it because no one would have served the station. Russia sold the station seats to other countries. Also, they hoped to sell Mir. This meant that Sergei had to keep the station working. Sergei's mission lasted twice as long as planned. As a result, he spent 10 months, or 311 days, in space and set a world record. During this time, he flew around the Earth about 5,000 times. Finally, he received the long-awaited message. He's coming home. Germany paid about $24 million for a ticket to the station. They were going to replace the astronaut. Krikalev got into the capsule and flew to Earth. Many people were waiting for his return down there. The cosmonaut landed, and everyone rushed to help him. He looked very thin, sweaty, and exhausted. 4 men helped him out of the capsule. They helped him stay on the ground, gave him a fur coat, and brought a bowl of broth. It seemed that such a flight would leave an imprint on his life forever. But the cosmonaut's mood was excellent. 2 years later, he went into space again and became the first Russian cosmonaut to fly on a NASA shuttle. And 2 years later, he was one of the first to live on the ISS. In 2005, he made his 6th and last flight. He went to the ISS, where he spent about 6 months, after which he returned home on the lander. After this flight, he set a world record for the total duration of stay in space at 803 days. Only 10 years later, someone managed to break that record, but that's a different story.
Imagine traveling to another planet on a journey that lasts for centuries, even millennia. Sounds crazy, right? Well, it might not be as far-fetched as you think. Scientists and engineers have been considering this possibility for a long time. And recently, a new study showed us how we can feed astronauts for as much as 6,300 years. Buckle up and let's find out what they learned. First of all, how do we feed people in space right now? Astronauts on the International Space Station, or ISS for short, can live there for several years. And they can't just pop out to grab a quick bite to eat. So what's the solution? Well, these astronauts have to rely on pre-packaged and dried food to keep them going. And no, they don't just eat astronaut ice cream all day, although that would be pretty cool. These meals are carefully planned for them to provide the nutrients and calories they need to maintain their health and perform their duties while in space. Currently, these astronauts consume about 4 pounds of packaged food per day. So the next time you get sick of your usual meals, remember that at least you're not eating the same thing for months on end in zero gravity. But these astronauts have been living in space for only a few years. Besides, they're still very close to our planet. Now, what about space adventures that last longer than your life? It's not as easy as packing a few ice cream sandwiches and calling it a day. Here, we face a number of problems. First challenge is the limited space available for food storage and production. Our regular methods of storing food, such as dried and packaged goods, aren't very practical for long-term space travel. Can you imagine how many jars we'll have to store to eat for centuries? Not to mention that after all these years, there won't be any vitamins in this food anymore. Another challenge is the limited resources available for growing and producing food. To survive on a closed spaceship, we need to recycle nutrients and resources like water and waste. So traditional methods of farming, such as using soil and large amounts of water, won't help us either. So what do we do? Don't worry, space pioneers, the answer might be space farming. That's right, folks, we're going to have to create a self-sustaining system. Astronauts of the future could be growing their own fresh foods, raising animals, and so on to feed themselves. We can also use traditional farming techniques to produce fish, dairy, and honey. Not only would this provide a yummy change from the usual dried space grub, but it would also help recycle nutrients, generate oxygen, and purify the air. Although there are still many challenges to be addressed, for example, how do we grow crops in microgravity? And how do we make sure the system stays self-sustaining over a long period of time? And most importantly, how can we fit it all in the cramped quarters of a spaceship? Actually, there's a possible solution for the last one. One way to maximize the use of space is through the use of aeroponics. This is a method of growing plants in which they can grow without soil. With the use of aeroponics, we can maximize the use of limited space. Pretty cool, right? As you can see, feeding astronauts isn't quite as simple as packing a lunch and heading out the door. But the good news is that we've already started testing these self-sustaining systems. There's a greenhouse in the ISS called LADA. It's been used to grow plants in microgravity since 2002. In this greenhouse, astronauts can grow fresh produce and herbs to mix things up a bit. Plus, it helps recycle nutrients and purify the air, helping to create a closed ecological system. It's basically like a little oasis in space. So right now, we're testing to see if this system could be used to sustain the crew on long journeys. Now, we know that the planets beyond the solar system are incredibly far away from us. So, how many years exactly would such a journey take? The closest exoplanet to us is called Proxima Centauri b. This exoplanet, or a planet outside our solar system, orbits the star Proxima Centauri. It's special, not only because it's just 4.2 light-years away from us, but also because it's located in the habitable zone of its star. In other words, it could potentially have conditions suitable for life. Scientists have even suggested that there could be liquid water on the surface of the planet, which, as we know, is a key ingredient for life. No wonder we want to visit this place one day, but the thing is, it would take about 6,300 years to get there with our current technology. So even though this planet is the closest one, this is a bit of a long flight. Not just a hop, skip, and a jump, you know? But let's imagine that we decided to go there now. We have thousands of years ahead of us. How will we evolve and survive in such a resource-limited environment? And, of course, how do we feed so many people since the ship is going to be multi-generational? That's the question that puzzled some European astronomers. Frédéric Marin, scientist at the Astronomical Observatory of Strasbourg in France, and his team decided to conduct a study on this topic. To answer our question, Marin and his colleagues used a numerical code called Heritage. And this is quite an interesting tool, the only one of its kind. This is a program code focused on multi-generational spaceships. It uses lots of scientific data and investigates their mathematical, biological, demographic, and statistical feasibility. Anyway, first, they calculated the annual caloric intake of the crew on board. Then, they compared it with our modern standards of agriculture. As a result, it turned out that in order to feed about 500 meat-eaters, we need about 0.2 square miles of farms. The study assumed that things like fruits, vegetables, starch, butter, and sugar would be produced by using aeroponics, which we talked about earlier. And ordinary farms will produce meat, fish, honey, and dairy products. And that's great! The results of this study are consistent with the forecasts of the Food and Agriculture Organization of the United Nations. Moreover, this is all taking into account aeroponics and microgravity. But some scientists believe that we'll need even less space. According to Mike Dixon, an independent researcher at the University of Guelph in Canada, previous studies have shown that if all these space travelers were vegetarian, they would only need about 8 square feet of land per person. This would include things like water recycling, oxygen production, and so on. So, if we cut out meat, we could take up less space and still maintain everything we need for life. This idea was picked up by Briardo Lorente, synthetic biologist at Macquarie University in Australia. He noted that in the future, we'll most likely grow food with the help of microbes. We're already gradually replacing animal meat products with microbe-produced foods. This way, we'll have delicious meat and won't have to bother with cattle. But the land area isn't the only problem that we'll have to face. For example, we know that plants grow slower in space. We can simulate things like light, temperature, and humidity, but gravity and radiation are much more complicated. We'll have to study these things for a long time to deal with them. Also, this new study doesn't address our most important problem, water. We more or less understand how to feed the astronauts, but what about drinking? We'll have to create a stable water circulation system inside the spacecraft. Marin and his team plan to address this issue in the future. They'll use the same code, Heritage, to find out how we can keep our entire crew hydrated for centuries. Anyway, it seems like intergalactic travels aren't as fantastic as they used to be. Of course, it will take years to make it a reality, but let's hope that one day we'll actually be able to grow tomatoes in the vastness of space.
The announcement day. Hello everyone and welcome to my space vlog. I'm so excited because I have a big announcement to make. After completing years of training, the day I've been waiting for all my life is finally here. I was always happy to be among the 350 people who have been selected to be NASA astronauts, you know. And here's a fun fact for you. The original 7 is included in that number. So it's fair to say I'm in the Legends League. But the great news is that now I'm finally done with the virtual reality lab and I'm actually going to go into space. There are so many things I need to do to get ready for my first mission. So I'll keep today's vlog short, but get ready to hear all about my space adventures in the upcoming days. The day before the launch. Now you would think the day before the launch would be a busy one for the crew, right? But it's actually quite relaxed in terms of things to do. Since the upcoming days are going to be stressful, NASA lets us spend time with some of our selected family members or friends who have been cleared to be near us during our pre-flight quarantine. We also get to stay at a beach house they own. Is this a dream job or what? But the most important thing we're advised to do today is to get a good night's sleep. That is, if you can, but no pressure. I'm going to try and do that now, so off to bed I go. It's a good thing that we were banned from drinking coffee 24 hours prior to the launch. Otherwise, I bet all the caffeine would prevent me from having peaceful dreams. Launch day. Today is the big day. First of all, although it's one of my favorite songs, I'm trying to avoid listening to David Bowie's Space Oddity, because ain't nobody wants any sad vibes. Secondly, coffee is not permitted for breakfast on the morning of the launch because of its diuretic properties. Having to use the restroom all the time can be a bit of a problem when you're going off to space in the cockpit, you know. Now, this may be a bit shocking for you, but other than all this, the astronauts have a significant chunk of downtime during a launch day. Before we depart for the launch pad, we do a final check and head to the restrooms for a pre-launch pee. Then it's time to climb into the cockpit. Many of us actually take a nap once we're there, as the system goes through thousands of pre-launch checks, including air-to-ground voice checks with launch control and mission control. And here's a fun fact for you. We wear adult diapers during this time, just in case. Alright now, let's eliminate talking about elimination for now. Well, now that everything is checked, it's time to start the main engine. Prepare for liftoff. 5, 4, 3, 2, 1. Woohoo! A day in space. Welcome to space. Now, I was going to say I will walk you through what a day for an astronaut on a space mission looks like now. But up here, I will float you through it. Now, first of all, every minute and every second of an astronaut's day in space is planned. From eating and brushing our teeth to working and sleeping, every move we make is based on a schedule. The things we have to do are planned down to 5-minute increments by a team in mission control called Ops Planner. This is crucial because these schedules show what is happening and who is involved with what at any given time on the space station. But don't worry, it's not all work and no play. Even if those are according to a schedule too, we still have free time to ourselves. Now, the concept of a day aboard an orbiting spacecraft is a bit different than what you might imagine. Every 24 hours, astronauts on board the International Space Station experience 15 sunrises and 15 sunsets as the station moves around the world. But for millions of years, humans have been living according to a 24-hour daily cycle. Our brains and bodies follow the circadian rhythm of waking and sleeping. That's why astronauts work and sleep to similar schedules that match these cycles and rhythms, because anything other than that would have us living in a state of permanent jet lag. Accordingly, an overall day for us looks like this. The workday is from approximately 6 a.m. to 9:30 p.m. Greenwich Mean Time, and it includes 3 meals and 2.5 hours of exercise. The morning routine. Our space morning schedule is sort of similar to our Earth morning schedule. We are awoken by an alarm, and we begin our hygiene routine with the stuff that is provided for us in our hygiene kits given by NASA. Those include rinseless shampoos that require very little water, since there are no genuine showers in space. The funny thing is, the water we use floats away during this. And each of us is allowed to take our choice of products with us in these kits, including cosmetics and toothpaste. There are razors to shave or clippers and scissors to give ourselves and each other haircuts if necessary. We just have to make sure to vacuum up that hair so it doesn't fly in our faces later as we're working. The food. We don't skip breakfast. It's the first of 3 meals we have, including lunch and dinner. When it comes to how much we eat, it really depends on the calorie necessities of each person. One great thing is that we don't really have to cook or do the dishes, since the meals are already cooked on Earth and come in disposable packages. You should know space food has improved greatly in taste and variety since Apollo missions, in which astronauts ate purely freeze-dried food for days. The space work. After we're done eating, it's time to get to work. Each of us settle down to the assigned tasks of the day. These assignments range from supervising experiments to performing routine maintenance on station equipment. Our work also includes checking projects that are controlled from the ground, as well as participating in experiments ourselves to figure out how well our bodies adapt to living in space for long periods of time. Space gym. Now, doing exercise is an essential part of our day. We actually commit hours every day to fitness. Normally on Earth, our bodies are constantly active because they're working against gravity to move. But with very limited gravity in space, movement is easier and doesn't require much work or energy. So, astronauts who spent a long period of time in space and didn't continue to train physically would lose a lot of muscle, which would leave them feeling weak once they return home. That's why it's vital for us to stay physically active to prevent bone and muscle loss. It also helps relieve what we call space snuffles that are caused by body fluids accumulating in the head due to not being tugged downward by gravity. Our regular exercise options include cardio using a treadmill or a bike. We do some weightlifting too. And to do all these, we have to strap ourselves down to the exercise machines because if we don't, we'll float away and our efforts would be for nothing. Free time. Mission organizers on Earth make time every day for us to relax and have fun here in space. This is when we write emails, watch movies, or even play an instrument. But to be honest, the most popular pastime in space is looking out the window to watch the Earth go by beneath you. There are also spectacular sunrises and sunsets to enjoy, which occur every 45 minutes as we orbit. So it's fair to say there's no time to get bored. By the way, just like Earthlings, we get weekends off too to recharge. Sweet dreams. It's important for us to get a good night's sleep to have energy for the next day's tasks. However, here in space, we can't climb into our beds. We have sleeping bags instead, which are attached to the wall to keep us secure. If they weren't, we'd be floating around all night, which sounds neither safe nor restful. Okay, I gotta go because I gotta go. Now, as a child, weren't you taught not to play with your food? Well, apparently these astronauts weren't. Floating Jell-O cubes across the cabin while in zero-G is a lot of fun, but it is also a sign of a potential problem called space euphoria. No one ever considered that extreme happiness in space could become a severe problem, but it can become a serious problem, and that's no kidding. For many years, space euphoria went undetected, although it was right there, front and center for all to see. When Apollo 14 astronaut Alan Shepard smuggled golf balls onto the moon and tried to create a tiny moon for the moon by attempting to hit a golf ball into orbit around the moon, everyone thought it was funny. Apollo 16 astronaut Charles Duke thought it would be funny if he tried to compete with the 1972 Olympic athletes back on Earth. He attempted to outjump the Olympic athletes to benefit from the 1/6 gravity on the moon. Duke jumped so high that he rotated onto his back and fell crashing onto the life support system in his backpack. It could have been a fatal fall if the bag had cracked. Duke's commander, John Young, said, "That's not funny," and it sure wasn't. Yet, when Apollo 17 astronauts began dancing and singing children's nursery songs while collecting rock samples, everyone still thought it was cute. Space euphoria again went unnoticed. As early as 1965, when Ed White became the first American to walk in space on a tethered spacewalk, his space euphoria became evident. He stayed out much longer than was necessary to test his mobility with the very first jetpack, or MMU as it was called, officially the Manned Maneuvering Unit. In his own words, "I'm not coming back. This is fun." Finally, when ordered to return to his Gemini spacecraft, Ed White said it was the saddest day of my life. Obviously, something sinister is at work with space euphoria. Weightlessness, combined with the view of Earth passing below, creates an exhilaration that overcomes all sense of duty. It is the great danger of space euphoria. Now, in hindsight, the effects of space euphoria could be seen when Apollo 17 astronauts drove the lunar rover on the moon. They exceeded the recommended speed limit and could be heard whooping and yelling as the rover rocked onto two wheels, even becoming airborne at times. Canadian astronaut Chris Hadfield was busy at work during his tethered EVA, extravehicular activity, when he paused to look over his shoulder. The glory of space smacked him in the face. He was so emotionally overwhelmed at the magnificent beauty of the Milky Way galaxy that tears began to fill up Hadfield's eyes. Now in space, tears do not flow down your cheeks. They pool up in your eyes. Hadfield had become blinded by tears of joy. But Hadfield, against protocol, refused to tell his supervisors on Earth. Only after he was no longer able to work did Hadfield speak a famous quote, "Houston, I have a problem." It was a direct result of space euphoria. Astronaut Hadfield managed to get back into the space shuttle, but his EVA was not fulfilled. Space euphoria had interfered. There is another aspect of space euphoria that deserves serious attention. It is something called the overview effect. Weightlessness in space affects everything from the physical and psychological health of the astronauts to the physics of using all the mechanical equipment of the spacecraft. However, weightlessness in space is not due to a lack of gravity. Astronauts orbit Earth less than 300 miles up, called LEO, low Earth orbit. There's plenty of gravity in low Earth orbit. The Earth's gravity keeps the Moon in orbit, and the Moon is about 250,000 miles away. In fact, a 150-pound astronaut would weigh 142 pounds in LEO. Weightlessness in space is due to free fall, not lack of gravity. What goes up must come down. The rocket blasts off, and about 8 minutes later, the engines shut off. The spacecraft begins to fall back to Earth. Fortunately, by this time, the rocket has achieved orbital velocity, which is about 17,500 miles per hour. So that it falls towards Earth but never hits the Earth. It keeps falling and falling around and around, precisely in the same curved path as the surface of the Earth. It's in orbit. It is free fall. Even though everyone calls it zero-G, it's not. If you were to place a bathroom scale under your feet when in free fall, it would show 0. You would weigh nothing. That's because the bathroom scale is falling too. The exciting thing is that astronauts retain all their muscle power. Their mass stays the same. Therefore, they can lift heavy equipment in space that would weigh hundreds or even thousands of pounds on Earth. Astronauts become superhumans in space, and that creates another unusual situation. There are lots of unusual situations in space. On the very first trip to the Moon, the Apollo 8 astronauts were not even scheduled to look back and photograph the Earth. Apollo 8 astronauts took only a limited number of pictures of Earth. That's unusual and kind of weird. But Earthrise from the Moon became perhaps the most influential environmentalist picture of the 20th century, and it wasn't even planned. But this is the key to understanding the overview effect: surprise at the unexpected. Even today, almost all globes of Earth are not of Earth. Globes in schools and libraries show each country, usually in different colors. Each country, sure enough, contains a star, but it is to mark the capital city of that country. It is not how the Earth looks from space. These globes are not globes of the planet Earth. In fact, it isn't easy to even find a globe of the planet Earth. Read the labels on these classroom globes. The geopolitical world. These are globes of a place called the world. There is no planet called the world. The world does not live in space. It lives on someone's desk or shelf. The definition of space is geological in origin. Space is defined as existing up to, but not including, the atmosphere of Earth. Earth isn't even an astronomical object. It explains why the very first mission to the Moon, the Apollo 8 mission, had not scheduled any pictures of Earth. Selfies weren't invented then. It also explains why the psychological impact of seeing Earthrise from the moon was so profound. It was a unique and totally new perception for which any and all humans were utterly unprepared. Seeing Earth in space was a complete surprise. Imagine yourself floating in space outside the spacecraft. You are surrounded by the Milky Way galaxy blazing with millions of stars. The planet Earth is a blue marble passing beneath your feet. Pretty heady stuff. How would you react? Would it change you? Apollo 9 astronaut Rusty Schweickart felt strongly that he was what he called the sensing element for humanity. What does he mean? It's the overview effect kicking in. Schweickart felt that he was connected to all the people on Earth. He compared it to being born into a new existence. And astronaut Schweickart is not the only one who felt the overview effect. Apollo 14 astronaut Edgar Mitchell had this to say about being in space. It was rather an extension of the same universal process that evolved our molecules, and what I felt was an extraordinary personal connectedness with it. I experienced what has been described as an ecstasy of unity. I not only saw the connectedness, I felt it and experienced it sentientally. I was overwhelmed with the sensation of physically and mentally extending out into the cosmos. Some years after returning from space, astronaut Mitchell started an institute to study the brainwaves of people who had been in space. And yes, they are different. According to Mitchell's institute's research, the euphoric sensation of oneness with the universe creates brainwaves similar to meditating monks. Mitchell's studies were so significant that NASA launched a special Space Shuttle mission in 1998 just to study the effects of space on the brain. The Neurolab mission studied brain cells of laboratory animals, and the astronaut crew too, as brain cells try to adapt to the freefall environment in low Earth orbit. Well, we can't all be astronauts, but now we can all access virtual reality experiences of what the astronauts saw in space. The internet has opened up our earthbound point of view to share the unity and oneness of the overview effect, and give us a small taste of the space euphoria astronauts get in space.
We interrupt this program to bring you this important message. The Earth is no longer fit for living, so you'll need to find your own new home. You immediately get the brilliant idea to apply for a job as an astronaut. You'll be able to wait over the hustle and bustle on the International Space Station until humanity finds a new home, right? The longest time a human has spent in space so far is 437 days and a few extra hours. And when I say in space, I mean the ISS, because a human being without the proper equipment in open space would only last a few seconds. The ISS is designed to support human life in space for extended periods of time. Extended, but not endless. The station gets resupplied with food, water, air, fuel, scientific equipment, and other necessities every 3 months. With no Earth or humans to send the mission, this lifeline will soon be broken. The station is a huge ship moving through space at over 17,000 miles per hour. It faces pretty harsh conditions, from radiation to micrometeoroids and huge temperature ups and downs. That's why the system regularly needs patching up. In addition to wear and tear, there are also unexpected events that can require resupply missions. In 2020, the crew discovered a leak that was causing a gradual loss of air pressure. They eventually found cracks in one of the modules. The crew managed to fix it, but it proves how important it is to have enough spare parts on board. Let's say the future humans will manage to find a way to run the station non-stop without restocking. Astronauts already grow plants in space in closed boxes with low-energy LED lights. It's not only a source of vitamins, without which humans can't survive, but a great mood booster. We'd also need more advanced closed-loop life support systems to recycle air and water efficiently. It's a system that captures carbon dioxide from the air by passing it through small beads. Then it uses steam to separate the carbon dioxide and transform it into methane and water. Water then divides back into oxygen. But even with all the possible advances, there's another problem: the health of the astronauts. They live and work in a microgravity environment, and they rely on carefully controlled life support systems. But our bodies aren't designed to live in weightlessness forever. It's like standing on your head, because the reduced gravity makes bodily fluids accumulate in the upper parts of your body. The result is a puffy red face. The gravitational force on the ISS is weaker than on Earth, so muscles don't have to work as hard and bones gradually lose their density. That's why each crew member follows a strict daily exercise routine. The heart muscle also weakens because it doesn't have to use as much effort to circulate blood throughout the body. Without Earth's protective atmosphere, astronauts are continuously exposed to cosmic rays. They are invisible waves that can cause some serious health issues. So maybe we're better off opting for Mars or the Moon for an alternative home.